Hey everyone. I don't think we should.
Thank you. Thank you.
Yes, we're on Zoom. So hi everyone and welcome back again. Maybe other people will join us later, but we'll see. So first of all, thank you all for coming, and I wanna show works that people did during this week following the day one. So first of all, this is Ron's shader, which is really cool. Let's see what else we got. We got Gena's boring meatballs, which is which is like yeah. Very, very unique stuff. Yes, metaballs. We got Shachar and Boris's domino piece, and that face you saw is apparently my SDF. So yeah, and they change the numbers, which is really cool. Eshed and Shachar's triangles. Yes. It's very, very cool stuff. Dan Cutting's Mandelbrot set, which is really, really cool. Dan Cutting did this. And Neria's spaceship, which is also really beautiful, very unique. I was working on fireflies, which I wanted to do for a while, so like it's 3D and like you can see, but it's like work in progress, so yes, every grass is just part of the same. So yeah, good job for everyone who participated and for those who assisted. And with that, let's get to today's dev seminar. So I hope you can hear me okay over Zoom. If not, please say something. So yeah, let's pick up where we left off. First of all, let's recap what we did last time. Okay, so we used SDFs to draw the dolphins, and then we we multiplied the UV or our space by some value larger than 1, and then we used the fract function, which again repeats values between 0 and 1 to create multiple boxes or columns. We can look at them again. Remember, we're drawing to the red and green channels. We can remove the dolphins for a second and see that we repeat. Also, like for those who forgot, we can just do the fract of UV, and then you can see that we repeat the range of 0 and 1 multiple times, and that's how we get we can draw multiple dolphins at once. So that was that. And now I want to talk about something that's similar to that, but also very, very important. So fract gives us the fractional component of a number, but we also have the floor function, which gives us the the floor of a number. And if you think about it, fract and floor are like the counterparts of each other. So right, because like if you have say 10.5, then the floor of 10.5 is 10, but the fract of 10.5 is 0.5, and then if you add them, you get the original number. So I can draw that, and obviously it's not going to look very interesting, but if you recall, when we draw, we clamp, we clamp when we draw the UV or something, it's clamped between 0 and 1 because colors cannot grow beyond that, and floor of a large value would probably give us, let's say, 1, and then 2, 3, 4, and it will all have the same color. So I can divide it, and then we can actually see like the boxes, right? And if I only looked, let's say, at columns, then you can actually see like the gradients of the column. And what's interesting about this is that every color is unique. So what we can say is that we have for each column of pixels, we have a unique number or an identifier that represents this entire column. If we draw the dolphins again, you can see that each dolphin is inside each column, and we have like some sort of an identifier for them now. So let's do that. Let's save it over here. So let's call it float ID equals the floor of uv.x. And yes, what's that?
You took the UV and you multiplied it by 10,
Mm-hmm.
and then you did floor and divided that by 10 as well.
I just divided it to show you that the values are unique visually, but I didn't need to divide. Yeah, it's like so. Okay. Exactly. So like the first dolphin would be, let's say this dolphin is column 0, so all the column will get value 0 and then value 1 and so on and so forth. Okay. So and now we have a unique identifier for each dolphin. But that's not enough, because again, like my motivation here is basically I want to make things more natural, right? And in nature we have some sort of like randomness, right? Because the dolphins at sea don't swim in unison, right? They like jump intermediately and stuff like that. Some are bigger, some are smaller, and we want to kind of have that here. So the next thing that I want to talk about is like one of the most important building blocks of procedural generation in general, not just in shaders, which is noise. Noise is like one of the most important parts. Noise is random value, or let's say random, like actually it's pseudo-random. And the reason it's pseudo-random is because it's very, very hard to get true randomness in computers. So we are going to simulate randomness. And we can use the randomness to make things look natural. Like we can use the randomness to make each dolphin of a different size and jump at a different point in time and stuff like that. So let's just for a minute, let's visualize randomness. So I'm going to write I'm going to use a hash function. I'll call it hash21. I'll explain why in a minute. So hash21 stands for yeah, exactly. So v is the seed for the hash function. Okay, so and it's float 2, so it has an x and a y. That's why hash2, and then 1 because we only get a single float value from it. Okay, now I'm probably not gonna make the best hash function in the world, but I'm just gonna, you know, but my goal is to say basically ping pong the seed value in a way that it's gonna be very hard for a human to kind of see the pattern in it. But again, it's not going to be a random in any way. And the output should be a value between 0 and 1, because it's very easy to work with normalized values between 0 and 1. So let's say I have this fract of, let's say, a sine of v dot x times some number. I'm just going to, you know, plug in some random numbers. And then let's say I add, I don't know, the sine of the other component of y times something, and oops, sorry, uv, yeah. Thank you. And let's say I multiply this too by some number, and then yeah, right, sorry, v. And let's visualize this for a second. So let's stop drawing the dolphins, and let's say call equals hash21 of uv, and you can see that we have like this noisy grayscale image, but you can see the patterns, right? It's like it's not really random. You can see that it repeats. So what's that? Yeah, because yeah, basically if I had like, if the UVs were not let's say if they were from 0 to 1 or something like that, it depends on like the range of the UV, and it depends on a lot of things. It depends also on the how zoomed in or out we are. Like if I multiply, you can like see different patterns. But the general idea is that we will try to play with the hash function in a way that a normal person would not be able to see the patterns. But this is how we generate random numbers. So actually, I don't really need a 2-1 function. I need just 1. Like I need single float v, which will give me, or seed, which will give me a noise. So I'm going to remove this. Okay, so I just have this single value. And now, instead of this, let's plug in the ID, right? So I have this hash, now it's 1, 1, and let's say I plug in the ID. Okay, this does not look right. Yeah, okay, this looks better, right? Something like that. Right, so you can see that now I again, what I did here was I used the hash of the ID. Remember, the ID is just the identifier of each column, and then I use the hash function for that. And now you can see that we have like different shades of gray for each column. So basically, like this shows us that we have like a different random number for each column. Okay, so any questions so far? Okay, so let's use that. So I'll make another value. I call it a float rand1 for rand, okay, for my random value. And now actually I'll move the time value t down here, and I'll say plus rand times 10, let's say. And now let's draw the dolphins again. And now you can see that everyone jumps at a different time, right? Because we shifted for each dolphin, we shifted the time a little bit. So that's like the first thing that we need. Also, let's get rid of this, if you don't mind. This was the SDF for the circle. It's not important anymore. Okay, so now that we have this, I want to control some more random factors about the dolphins. So let's call this, and okay, so I could use this random value for controlling all the different parts. Like I could use the same random value for determining the size of dolphins and how frequent we should have dolphins. But I think that I don't want to couple like all the different parts, right, of the randomness factors with the same random value. I don't want all the dolphins that start, over here, right? Wait, like over here, or oh wait, this is the camera. Okay, so I don't want to, I don't want all the dolphins that start over here to also be of the same size or something like that. So I can just, let's say, I'll call this random1 instead. And I'll now copy this and call this next one random2, but I will shift it a little bit or play around with the numbers, just again, plugging in random numbers just to get a different random value. And now for the same ID, for the same seed, I get a different random value, right, for the same ID. And I'm going to use that now to, let's say, to scale the dolphin. So let's do a little bit of a house cleaning here. So I'll call this dolphin offset. Okay. And now I'll make dolphin scale, and I'll do something like this. I'll do 1 plus random2. Why? Because because random2 is a value between 0 and 1. So now I'm going to scale something between 1 and 2. So dolphin either stays the same size or it's going to be twice as small. So I can just do this, and you can see that they each have their own size. And I want some more control because I don't want a dolphin for every column. That looks weird. I want, so I will make another value, which I'll call ShouldAppear. Okay? Yes. What's
go smaller instead of larger?
Because if you recall, we did the same thing with the UV. Okay, so I'll repeat the question if the audience didn't hear. Why do they grow smaller rather than larger for multiplying by a value larger than 1? Because for the same, yeah, exactly. We make the space bigger, so everything inside of it, because when we grow, we make the space bigger, everything grows smaller. I can also show it to you in this graph over here. So if I multiply it by 10, like now it's like it goes from -6 to 6, right? If I multiply it by, I don't know, 4 or something like that, it would grow from minus, I don't know, like 40, like 60 to 60, like if I multiply it by 10, right? So that's why. Okay. Okay. So now I want to make some dolphins disappear because I don't want them to be so dense. So I'm gonna make a ShouldAppear function, and if you recall, we have this step function. Remember, step is a function that gets 2 parameters. The first one is the threshold, and the second one is some value, let's say x. If x is smaller than the threshold, we get a 0, and if it's larger, we get 1. So it's basically like saying larger than. It's like the same thing, but it's more mathematical, and we don't like ifs in shaders because they make them slower. So we'll use step instead. So first of all, let's determine the chance to see a dolphin. So let's call it chance chance 0.5, let's say, and now, or let's say 0.3, and now I want to actually again, because the step will give us 1 only if we get values larger than the chance. So I want to actually do 1 minus chance, and then I'll do another random value. So I'll explain everything in a minute. Let's make another random value. Let's say 6, and I don't know, 13 or something. Okay, so I did 1 minus chance because now this actually is 0.7, right? So only values which are larger than 0.7 are actually going to give us 1. So only dolphins with more than 0.7 are going to appear, and there we go. So now we have less dolphins, and this looks a bit random, which is nice. Okay, I think that's enough dolphins for now. Let's talk about the sea, okay? Because dolphins need to swim somewhere. So actually, let me save this, the dolphins. Let's call it dolphin val for value, and now let's draw the sea. So let's say float sea val. Right now it's going to be 0, and I'm going to make the color be the sea value. Okay, so this changes nothing, but it's easier to work with. Okay, so now to show the sea, first of all, I want to draw a plane. Okay, so I'm going to use basically like another new SDF, but a very simple one, just to draw like a plane. I want like all the bottom part to be white and all the top part to be black because I'm ignoring it. So that's pretty easy to do. I can just do a step of 0 and the uv.y. But it's flipped, right? Because I wanted the white to be on the bottom because the sea is going to be over here. So I can just use the negative. Okay. And again, if you remember, for these kinds of things, for drawing, I don't really like to use steps because the line is like a perfect line. We want to blur it a little bit. So I'm just going to do a smooth step instead. So let's say 0.1 and 0.1, and now we have this blurry line. And that's nice. That could be kind of like our sea, but it's not good enough because obviously the sea isn't flat, right? The sea has waves. Maybe the Earth is flat, but not the sea. So what we can do is basically like add a sine function because sines are waves, right? So I can do this. So uv.x, and now we have some waves. But wait, it's not good enough because it's like way too wavy. Yeah, it's way too perfect of a wave. So let's talk about sine waves for a minute. Okay, so yeah, these are sine waves. And what's interesting about them is that they are these perfect wave function that goes from 1 to negative 0.1, and they repeat after every 2 pi, right? Everyone knows that from elementary school. But even if you don't remember it, we can manipulate this function to give us much more interesting results. So the first thing that we can control is the amplitude. If we multiply the result of the sine wave by some a or amplitude, we can control how, like the maximum and minimum of it, right? So I can make it go from like 0.3 to negative 0.3. Or if I multiply the input or the x value, I can control the frequency of, or like how dense the waves are, right? And if I add to the sine wave, I can shift the waves, okay? So I can move them around. And that's, these 3 things are going to be very, very useful for us. So instead of doing just this simple wave, we can, let's say, multiply by something smaller, and we can also add multiple sine waves, where we can, like, let's say we also have the uv of x, but this time I'm going to multiply it by 2, but I'm going to make it a much less amplitude of a wave. And another thing that, what's that?
Max between the 2 waves.
No, not a max. I just add them together, so we get like these weird shapes. And another interesting thing is that I can just add, let's say, the uniform.time, and then we actually get some animation for the waves. So yeah, that's pretty useful. So I hope you'll forgive me, but I kind of wrote a function. I just played around with the values and I got to something that I liked. So just going to use that. Actually, let me use the hash function too, because it's a good hash function. I'll remove this. Okay, yeah. So yeah, instead of all this, I'll just add the C height. I called it the C height of uv.x. Sorry, uv.x and uniform time. And yeah, I'll just change this to this instead. Okay, and I kind of like these waves. So now we want to kind of so now that we have all this, we can combine the dolphins and the waves, right? So we can do something like call plus equals the dolphin val, and now we have dolphins and the sea as well. So that's a good start, right? But I'm still missing some stuff. I'm still missing some animations, like because yeah.
How can you make the which dolphin appear change over time? Not be the so you have a chance that controls which appear.
Mm-hmm.
How would you change it so it's different dolphin each time and a different column?
Since okay, I'm gonna animate the columns and then different dolphins will appear because I'm moving them. Okay, so this is just what I was getting. Yeah.
But if we can connect the chance function to the time, that
yeah, but I don't want them to disappear in the midair, you know. So right. So yeah, that would be weird. But okay, so but don't worry. Like yeah, obviously it's weird that they're jumping in place. So let's make it like the way I imagined it when I was working on it. I was thinking I want to like the viewer should be like on a boat and they like we swim and so we swim that way. Okay, so the sea should be moving to the left, right? And the dolphins would swim with us, so they should be moving to the right. Yeah. My right, yeah. Everything is flipped for you, yeah. So let's try to do that by let's do this. So for now, I'll make another float value. I'll call it pan offset because I'm panning the camera. Okay, and right now it's just going to be the time. And if I think I need to subtract. Yeah, if I subtract the panning offset from the sea moves to the left. But I need to fix the dolphins. I don't want to manipulate the UV directly over here because I want like to have. I'm gonna make a copy of the UV for the dolphins, so I'm gonna make a float to dolphin UV. Okay, and I'm just gonna do the UV. The float to of uv.x plus the panning offset and uv.y. Yeah, I think that's the right one. And then if I replace things around, yeah, don't worry. Yeah, okay. Now things are moving. Yeah, they obviously jump a bit too high, so we can fix that. Yeah, but it's easy to fix. Yeah, we can just move them down a little bit and it looks better. Also, like they still jump too far, so for that we can kind of manipulate the panning offset and then they jump not as far. So we can it's a lot of tweaking with values, so I'm not going to get too much into that because it's a waste of time for us right now. So we got something that's very close to being complete, but we're still missing colors, obviously, right? Because it's all just black and white, and that's not very interesting. So everything we did so far, the black and white just shows us the intensity of everything. So we basically don't know where the sea should be and where the dolphins should be and where there shouldn't be, but nothing beyond that. So I kind of found colors back home, so I'm just going to copy all of them for a second. Yeah, and now, so instead of the dolphin value being just a float, I'm going to make it a float 4. I'm also going to use the opacity, but I'll get to it in a minute. So now I'm going to multiply this thing by everything, all the intensity. I'm going to multiply by the dolphin color. And if we kind of visualize that, so I can just do, yeah, I'll just do this. So now the dolphins actually have colors, right? Which is nice. And now let's do the C. So I'll just multiply the C by C color. Yeah, and then the float 4, thank you. And RGB. And now if I add them together, it's not going to look very good. I'll get to it. Okay, so now when I add them together, obviously it doesn't look good. And the reason this happens is because we increase the channels or the pixels value for the dolphins that are within the sea, right? That's not a good solution. We didn't see that when we drew the white part because it was white over white, but now it's visible and it doesn't work. So now we need to talk about blending. We are going to use something that's called a normal blend for anyone who worked with Photoshop before, or basically using the opacity, which is why it's a float 4, to kind of blend things together. So I want the dolphins to be behind the sea, basically meaning if the dolphins is diving in, we don't see it. We only see it when it pops out and it's in the air, right? So to do that, we are going to use something called the mix function. So mix, and the mix function, for anyone who doesn't know, it's basically, it looks something like this, A, B, and T. It means that it interpolates, it's a linear interpolation for anyone who's familiar with the term. It interpolates between A and B with T. What this means is T is a value between 0 and 1, and A and B are floats or vectors or something like that. It doesn't matter. And when T is 0, we get just the value of A. When T is 1, we get just the value of B. And when T is somewhere in between, we get a mixture of those. So like if T was 0.3, we'd get 0.3 of A and 0.7 of B. So some sort of blend. Okay. So what I want to do now is I want to blend the dolphin and the C by the C alpha. So I'll just do let's say RGB and C val.a. Yeah. Okay. And now the dolphins, whenever they reach the sea, we only get the sea color. But when they're in the air, we only get the dolphins because the sea is invisible over here. Okay. All right. So this is close to being what we wanted, but it's still weird because like I want layers. I want, like, when you look far away to the sea, we like see like different kind of layers of the sea, right? And then you can see very far away. So let's move pretty much all of this into its own function. Let's call it, let's do it over here. Say I'm gonna make it a float 4 layer. It's gonna get a float 2 of UV, float of time, and yeah, that's it for now. And my color is gonna be a float 4 now. I get to Y soon. And I'll just return it. And yeah, and everything now, the time is not uniform time, it's just time because we get it as a parameter over here, right? Okay. And again, like I can just draw it right back if I did layer of UV and uniform time, right? Then dot RGB, nothing changes because all I did was just move it outside. But now I want to actually make layers. So to make and then blend them, obviously, we're going to blend them just like we blended the dolphins in the sea, so that every layer, every like layer that's closer to the foreground, closer to us, is going to hide everything that's behind it. So now I'm actually going to use a for loop, and I'm going to do it in a bit of a unique way. So instead of just having an integer grow from 0 to some number, let's say I have float layers num for the number of layers. Let's say I have 5 layers. So my I value is going to increase from 0 to 1, and it's going to increase by I plus equals 1 over layers num. Okay. Yeah. It's fine. It knows because it's a float. Yeah. And okay, so my I increases by 0.2 every time, and it's going to be useful for me in a minute. Okay. So first of all, let's draw the layers. So I'm gonna do float for layer equals, right, layer with the capital L, UV and uniform time. Yeah, and I will have my color, which right now is going to make it 0 to begin with, and now the color is going to be a mix of itself. So like, should I remain the same, and the new layer depending on the new layer's alpha channel. And we're not going to see any change over here yet because all the layers are drawn exactly at the same place. So to fix that, what we want to do, so I'm gonna send the layer the I value. I'm gonna send the layer should know which layer it is. Okay, so I'll just say float I, and now let's do something. I'm gonna make I'll call it a lower value, float lower, and I want to also interpolate it. So mix of, I think, something like this. Sorry. Okay, and I'm going to do so it's a number that grows, right? And I want to add that number to the y value of the ux, the uv, sorry. So you see, I basically I shift every layer down by adding that number. And so now we have multiple layers. Obviously, the dolphins are in the same timing, and that looks weird, but at least we have multiple layers over here. So that's like the first thing that we want. And now, yeah, and so we get the mix and we get that. So obviously we need to randomize like each layer, right? So that they're not the same timing, but we're kind of gonna get that, I think, for free if we try to focus on something else right now. So let's talk about parallax. So I don't know how many of you have ever heard the word parallax, but what this means is, let's say, like recall when you were driving, like where your parents were driving you somewhere, and you looked out the car window, and you looked at like at the trees that are close to the road. So they were very big, right? And they move fast. They like shift fast, right? And then if you look very far away, you see like smaller houses and trees, and they move very, very slowly. And the moon is following you, exactly. That this is called parallax, and it's like it's the sense of depth. These like small things make things look like they're far away to our brain. So we can kind of imitate that. So let's start by basically scaling down or making things smaller the farther away they are. So again, same trick. We're gonna do the farther layers. We're gonna multiply them by a large number, and then the closer ones by a smaller number, and already we kind of get this. Yeah. Any questions, by the way? I'm not stopping. I like I should stop. We all good? All right. Hypnotize is good. Okay, so we scaled everything down. Now let's but they all move at the same speed, which is obviously bad. So let's play with that. So let's call this, make a scroll value. I think I remember the values I liked. So
the closest ones move the fastest.
Exactly. Where did I make the, oh yeah. Okay, so the pan offset shouldn't be here. It should be, let's put it over here for a minute. And now we'll multiply the panning by the scroll. And now you can see that the closer ones move fast and the further away ones move slower. And that's already way better. Yeah, and they make a large jump, I know. I told you, we need to tinker with the parameters. I'm not gonna do that. So just imagine it's fine. Yeah, I can play around with it forever, but it's not gonna benefit you in any way. So we're gonna just accept it for a minute. Let's also make the waves, like the closer one was wavier and the further away ones less. Yeah, so I think these are the values. Yeah, I'm pretty sure. So yeah, I'm gonna remember we have the C height and we can feed the waves. So yeah, you can see that these waves are less wavy and these are more wavy. So that's better. And also, okay, yeah, I'm sorry about the huge jumping. But another thing that I would really like is also, like, again, like imagine that you're outside looking at the sea or at, I don't know, like a mountain range or something. When you look really, really far away, the further away you look at something, the more grayed out it is, right? Because we have haze, right? There's haze, dust, and the further away you are, hazier everything appears. So I made a haze color, which is just some gray value. And now I'm gonna blend in the gray to the furthest layers. So I want to say, remember that the value of I is 1 when it's closest. So I'm gonna do yeah. So I'm gonna make a mix of haze. I think it's haze and color RGB over I.
Shouldn't the wave be after the parenthesis of the C height? Because you multiply the wave by time instead of this. I think you wanted to.
No, I wanted to control not the C height, but the intensity of the waves themselves. So it's fine.
Yeah, so this is you're
What's that?
making it move faster.
I wanted to make them move slower.
It's still the same.
Yeah, you're right. You're right.
Okay, faster.
You're right. Actually, I meant the speed in my mind. Yeah, not the. But you're right. Maybe it could look better if I multiplied it by the height itself. I don't know. Maybe both. 1 second. Why is it not working? RGB, haze, color. You're right. Okay. Yeah. Okay. And this looks way better. And now the alpha, no.
So that the fastest becomes like
Transparent, but I don't want them transparent. Like this is instead of being transparent for me, they just become grayed out. So it's like they're yeah. Well, the reason why white looks weird to you right now is because the sky is black, and obviously the sky shouldn't be black. So let's fix that as well. That's like probably the easiest one, but I waited with it for a while for some reason. So we have 2 sky colors, and I'll make a gradient over the y coordinate of y. But I'll just, it's not good enough, but now this looks nice. So yeah. We can tweak around with the parameters for days, but basically like this is what we get. And yeah, I think this is pretty much it. So.
you submitted to the
Yeah, this is very close. My result, in my final result, they don't jump this way. But yeah, other than that, it's very, very similar. Yeah. But yeah, any questions? Any? Yeah.
What was the style guide used for you coding?
There is no style guide. Actually, shaders in Shader are infamously known for having the worst, most cryptic code in the world. So yeah, good luck. Yes, I did, but it's not that bad actually. I think it's obviously not perfect, but you should try to read some of the more famous shaders over there. It's impossible. Eden?
I think you have something wrong with your blending.
What is wrong with my blending, Eden?
It looks weird.
Yeah, the black part over the edges.
Yeah.
Yeah.
I think you should multiply something by alpha. I don't remember what, but your mixing of the doesn't.
I think it could be some gamma correction or something like that I'm missing. I see people.
You multiply the same value with the alpha and the colors.
I think you need to multiply by the C alpha. Something
When he
I think
when he multiplies, when he gets the colors, he's multiplying a value with the C color. He should set this value as the alpha of the C color. That will fix it.
I'm sorry.
Line 116 and 114, you are multiplying the intensity.
Right. Right. Yeah.
You should set the intensity as the alpha of the color.
You're right. Yeah.
So that the alpha gets.
Yeah. You're right. But I'm not gonna get to do that right now because it's not important enough for the basic level of understanding that I'm trying to reach here. So. But you're right. You're right. Yeah. Tech transfer will fix it. Yeah. Any other questions? We could add clouds and stuff like that, but I was too lazy. Actually, by the way, like this is not part of what I intended to talk about, but like we used like this grainy noise, right? This non-continuous noise, but there are some noises which are continuous. So there is something called Perley noise. Perley noise is very, very interesting. It's a continuous noise, meaning it looks like waves if you look at it in 3D. And the mathematician that made it was the first mathematician to ever receive an Oscar award.
Your noise is
So-
a bit continuous. It's like
Yeah,
you
yeah.
give it,
Yeah, large
it's
yeah.
very values that are very close to
Yeah,
each
you're
other,
right.
you get
You're right.
using the continuous function.
You're right, but but I'm using a fract and people usually use dot products and stuff like that to kind of really try to play around with the numbers, but I was lazy.
How did you learn this? Did you reverse engineer other shaders? Or did
I
you-
wish I did not reverse engineer the shaders. I wish I was that smart. No, I saw a lot of tutorials, both in the website that I sent. There is a guy called Inigo Quiles, who is like a genius in everything. Is the one who had the website I sent, which in there he shows about a bunch of SDFs and a bunch of techniques, both in 2D and 3D. And also there is another guy. He has a YouTube channel called The Art of Code, and he teaches how to do these things. And kind of like me in the sense that it's like he's live coding stuff, but he's way better, and like he's also like a genius, and he does like really, really interesting stuff. So you should definitely check it out if it's interesting for you. Anyone else? Yeah.
If you could finish with so long it felt small.
Anyone with a real question? Well, so long and thanks for all the fish.